Hello M2, this is Teacher Win and this will be our last lesson for this unit. So for this video, we are going to talk about distance, displacement, speed, and velocity. Again, distance, displacement, speed, and velocity. For more information about this topic, you can read pages 38 to 42. Now let's start first with distance. So what is distance? Distance is defined as how far an object travels. So like for example, if I have here my so-called reference point, and if I move to this direction, so which is a linear direction, so how far is it? So if I move from my reference point going up, so how far is it? So we are asked about how far an object travels if we talk about distance. So please take note, so the direction is not important in distance. So even if you move here, like for example, this one is 3 meters, so only 3 meters, no need to say 3 meters to the right, right? Or even if you move here like going up, shall we say this is 5 meters, so only 5 meters, you don't say 5 meters up. Also, so we have here an example of your ant that is crawling along a ruler. So let's try to look at this ant moving on top of the ruler. Okay, so the ant moves from 0. So my 0 here is my reference point. So it moves in a linear direction going to 3 centimeter. So what distance did the ant travel, or how far does the ant move from 0 centimeter or from the reference point? So as you can see here, so the ant moved from 0 going to 3. So therefore, the distance, or represented as D, is 3 cm. Once again, distance does not depend on direction. So you don't care if it moves up, down, right, left. Okay? So let's try to look at this ant again. So moving on top of the ruler. So as we can see, the ant moves from 3 going back to 0. So 3 here is your reference point, and it moves in linear direction going to 0. So what is the distance, or what distance did the ant travel? So as you can see here, so the ant moved from 3 to 1, 0. So that means the ant moved 3 centimeter. But you don't have to include the direction. So the question here, does this direction change the answer? So actually, no, nah? So still, even if you start from 0 going here, that's still 3. Even if you go back to 0, that is still 3. So that is all about distance. Okay, so let's add more information about distance. So let's follow this ant again. So as you can see here, so the ant moves at least 2 times, right? So the first one is from 0 going to 5. And then from 5, it goes back to 3. So the question is, what distance did the ant walk this time? Okay, so the answer is 7 centimeter. So again, so you are asked of how far does the ant move? Okay, so the ant moves from 0 to 5, right? So that is already 5 cm, right? So the ant moved from 0 to 5, that is 5 cm. And then from 5 cm, then the ant moved again to the left by another 2 cm, right? Because 5 cm to 3 cm, or 5 minus 3, that's 2 cm. So 5 cm, and the ant move again for another 2 cm. So that means the total is 7 cm. So that's why the distance is 7 centimeters. The next word is displacement. Displacement. So what is displacement? So displacement is the difference between an object's final position and its starting position. Starting position, or another word for this is initial position. Okay, so this is what I mean by displacement. So if I have here a ruler, this one is 0, 1, 2, 3, 4. Now, this is my reference point, meaning this is my initial position. Okay, so if I move here, going here, okay, so my 0 here is my starting position, right? And my 3 here is my final position. So, how far did I move from 0, or from my starting position to my final position? So, I move at least 3, shall we say 3 cm. So, therefore, my displacement is 3 cm. Okay? Now, let me give you another scenario. So, if I have here my 0, 1 cm, 2 cm, 3 cm, 4 cm. 0 is my starting position. Now, let's say I move 2 times. So, I move from 0 to 3. Okay, then I move again from 3 going to 2. So, what is my final position? Is it 3 or 2? Okay, very good. So, my final position is 2, right? So, if we talk about displacement, you are asked about the final position and starting position. So, what is the distance from my starting position and my final position? Is it 3 or 2? Okay, so the answer is only 2. Na? So, the displacement from this example is 2, because my final position is at number 2 and my starting position is at or at 0. Let's continue. So, in your displacement, direction is important. Again, in displacement, direction is important. So to get your displacement, so you have just to subtract final position and your initial position. Or you can write it this way, the final minus the initial. So again, so in order to define displacement, so we need directions. Okay, so example of directions, like your positive or negative, or it can be your north, south, east, or west. So let's go back to my example. So in here, so I told you the displacement is 3 centimeter, right? But we need to add direction. So what is this direction? Is it right side or the left side? So 0, 1, 2, 3, this is right side, right? So 3 centimeters to the right, or you can just say 3 centimeters to east, or you can also say positive 3 centimeters. Okay, going back here, our displacement here is 2 centimeters, right? But we have to add direction. So 0 to 2, is it right or left? So this one is right, so 2 centimeter right, or you can say 2 centimeter east, or you can just say positive 2 centimeter. So this time, let's compare displacement versus distance. So our distance here, example, is 3 centimeter, And then our displacement here is 3 centimeter to the east. So please take note, there is a direction of your displacement. So remember, an object's distance traveled and its displacement aren't always the same. So I will give you more examples about this one. Okay, so our displacement here, so let's go back again to your ant. So this is the ant that is moving from 0 centimeter to the 3 centimeter. So if you will ask about the distance, you will just write 3 centimeters. For displacement, you will going to write plus 3 cm. Remember that the word or the symbol plus, it means east, right? Or it means to the right. Okay, now let's continue again. So let's find the ant's displacement again. So this time, so the ant is now facing to the left. So that means the ant is going back to 0. So again, so the ant in this example is going back to 0. So the distance is 3 centimeters, right? So we don't add the direction. However, if we talk about displacement, so the ant moved from right going to the left. This one is going to the left direction, so that's why we have your negative sign. Negative symbol here, it means to the west, or this is your left side. Okay? Okay, this time let's have more examples about your displacement. So we have here, so find the displacement and distance of your ant. So the ant move from 0 to 5, then from 5 to 3. So the ant move at least 2 times. So what do you think is the distance? So the distance is 7 centimeter because the ant move from from 0 to 5 centimeter, and then it goes again to 5 to 3 centimeter, which is 2 centimeter. So that's why your answer is 7 centimeters. How about the displacement? Okay, so the displacement for here is 3 centimeters. Again, so displacement is 3 centimeters. So it's 3 centimeters because, again, displacement is final position and your initial or starting position, right? So our starting position here was 0, right? This is our starting position. And 3 here is our final position, right? So therefore, so that is your final position minus starting position. So final position is 3, right? Minus starting position, which is 0. That's why it's 3 centimeters. But why is it is still positive? Teacher, it goes to the left, right? So it should be negative. Take note, M2, 0 going to 3. Is this right side or left side? This is right side, right? So even if the ant is going to the left, but his final position in reference to his starting position, it's still on the right side. This one is still on the right side. So that's why we will write positive 3 centimeters to the east or to the right. Okay, so let's try to look at this track and field. So imagine you are the runner. So the circle here, this is the person that is going around the track. So I want you to look at how many times does this person is moving in the track. So let's read first our example. An athlete, so this is the person, runs around a track that is 100 meters long 3 times. So what is the athlete's displacement or distance and displacement? So the athlete is running 3 times. So 1, 2, 3. So the question is, what do you think is the distance? Okay, so the answer is 300 meters because the person or the athlete is running 3 times. So each time that he runs, he can finish 100 meters. So 100 meters times 3, so you will get 300 meters, right? However, how about the displacement? Okay, the displacement is 0. Teacher, why it's 0? Again, what is our starting position? Our starting position is this one, right? So this is your starting position. Where is our final position? This is also our final position. So our starting position is 0, right? So that means, so our starting final position minus starting position, so that will be 0 final position minus 0. That's why we'll get 0 meters. Okay na? So to put it simply, in displacement here, we just go back from our starting position. That's why the displacement is 0 meters. Our next concept is about speed. So speed is the rate or how fast an object is moving. So basically, so speed is expressed is as this way. Speed is equals to distance over time. Or we can just simply use the triangle here. So this is speed, distance, and time. Okay. So to explain, let me just explain this one. So to use this triangle, it's like this. Here at the bottom, it means multiply. If one is on top and one is at the bottom, it means divide. So that means using this triangle formula, so we can get speed, right? So we can get speed. So D is on top, T is at the bottom, so that means D divided by T, right? Another, I what if I want to get the value of distance? So distance is letter D, right? So D is equals to, look at it here, I told you, right? If they are at the same level, it means multiply. So that is distance is equals to speed multiplied by time. If I want to get the value of time, D is on top, S is at the bottom, so that is distance divided by your speed. Okay, so let me just edit this one. So we should use small d because we are talking about distance here. Okay, let's continue. So this is how you show it in a simple way. So like distance, so speed does not depend on the. Let's look at our example here. So a car drives 100 meters in 5 seconds. So let's try to look at the animation. Okay, so what is the car's average speed? So we have to use only the formula S is equals to D over T because we already have the value of distance. 100 meters is your distance and 5 seconds is your time. So using your S is equals to D over T, so we can get 20 meters per second. So the slash here, so this one, it is read as meter per second. So this one is your meter, the slash here is your per, your S here is second. Now let's try to compute this one. So a rocket traveling at 10 meters per second, so how long does it take the rocket to travel 30 meters? So looking at our equation, we are looking for the value of your time. How long it means time. Okay, so using your triangle formula, right? So in your triangle formula, you have your S, D, and T. So I want to get the value of T, so I'll just have to simply T is equals to D is on top, speed is at the bottom. So I will use this formula. So given here, so our given value is speed is 10 meters per second. Our distance is 30 meters. Our time here is we don't know. So our formula is T is equal to D over S. So our solution, that will be T is equal to D over S, right? So distance is 30. I will remove the symbols now, or the unit. Second, or speed, I mean, speed is 10. So 30 divided by 10, so you have at least 3. 3 what? This is time, so this is 3 seconds. So this is the final answer. So how long? So the answer is 3 seconds. Here is another problem. A race car is traveling at 85 meters per second. How far does the car travel in 30 seconds? So if you look at the problem, so how far, it means distance, right? So let's go back again to the triangle. So speed, distance, and time. So I want to get the value of distance. So distance is equals to, look at it here, they are at the same level. So that means multiply. So multiply speed by time. So our given here, so this we have our speed. Our speed is 85 meters per second. Our distance here is we don't know. And then time here is 30 seconds. So to solve this one, so we will use the formula D is equals to speed times multiply. So D is T, so D is X, S is 85. So multiply it by 30. So how much will you get? So you will get a value of 2,550. 50 what? What is the unit? This one is distance. So this one is more of meters. So this is the answer. So to answer this one, how far does the car travel in 30 seconds? So the answer is 2,550 meters. Our last part is about velocity. So velocity is just speed with direction. So for your formula, it's almost the same with speed. However, we just change distance into displacement. Okay, so this time it has a magnitude and direction. So again, magnitude is your number, right? And then direction is you have your north, south, east, west, or positive or negative. Okay, now let's summarize this one. So we will now combine distance, speed, displacement, and velocity. So let's look at the ant here. So back to our ant explorer. So the ant is moving, okay, for 5 seconds. So we can see here that the ant move at least twice, from 0 to 5, then from 5 going back to 3. So what is our distance? So the distance traveled is 7, right? Because that is from 0 to 5, so that is 5 cm. And then from 5 to 3 cm, that is 2 cm. So that will be a 7 centimeter. How about the displacement traveled? So that will be 3 centimeters, because our final position minus starting position. Our final position is at 3 centimeters, right? And then our starting position is 0. So that's why we're going to 3 minus 0, we have 3 centimeters. But this one is still on the right side, so it is positive. Next, how about the average speed? So we just simply have your distance divided by time. So our distance here is 7, right? And our time here is 5, so you just divide it and you will get a value of 1.4 centimeter per second. And for our average velocity, so it's different now. Why it's different? Because instead of using your distance, we are using the value of your displacement. However, the time is still the same. So therefore, so the average velocity is displacement divided by time. So 3 divided by 5. And you will get an answer of 0.6 centimeters per second. But take note, here is now the direction, which is your positive, which is still on the east side or the right side. So for your homework M2, so please answer page 43 and 44 of your book. Also, please answer the unit test. So it's a very long activity. So that is from page 49 to 53. So that includes the topic starting from force until to the last topic, which is your speed, velocity, distance, and displacement. So this is the end of the video. So I hope you understand about the difference of the four lessons that we have this video. So please submit your homework in the Google Classroom. So if you have any questions, you can just message me online. So once again, thank you very much for listening, M2, and have a great day.